Hello again. Today we're going to talk about how to graph tangents and cotangents. I do have a short video that I'll link to at the end of this one that explains why the graph of tangents and cotangents look the way they do. So I encourage you to take a look at that if you're not familiar with what those graphs are. But today we're going to talk about physically how to graph those things. Now, I'll mention a couple of things. The examples I'm going to do, we're not going to worry too much about horizontal shifts or vertical shifts. We're just going to talk about what the A value does and how it affects the graph, and what the B value does and how it affects the graph of these things. So on the screen you see already kind of the steps to graph tangent. I'll let you read that to yourself. You need to pause that. But that's really what's going to go on. You'll notice two big differences between graphing sines and cosines, and that is our period for tangent is just pi. And if you think of your unit circle, we know that in quadrants 1 and 2, the tangent goes from positive to negative, and then it kind of repeats that same process, those exact same values in quadrants 3 and 4. So the period is only pi, so we're going to find the period by doing pi over b. And for that reason, for sine and cosine, we divided the period by 4 in those different sections. Now we've only got to divide it by 2. So again, there's the rest of the steps. I'll let you read that on your own. If you need to pause that, if you want to jot those down or what have you, then you can do that. But I'm going to jump in here and do my first equation. And I guess before I do that too, I'll go and show you just what the graph is going to end up looking like. So this is our parent function of tangent. And you see it has some vertical asymptotes in there and kind of those, elongated S-type shapes. So we're going to see, and again, if you want to know why they have that shape, I'll link to that video at the end of this one. So here we go. Here's our function that we're going to graph here. F of x equals 2 tangent 4x. And just based on what we knew from sine and cosine, you should be able to find your A and B value there, and then the period and the tick marks. So we know here A is going to be 2. The B value is 4. Period would be pi over 4. Can't do anything with that. And then the period divided by 2 would end up being pi over 8. And just like I did with sines and cosines, we're going to transfer that onto the graph. To save a little bit of time, I have already done that. So there is my ready-to-go graph. I got the same information, same equation there. And you see my tick marks are labeled on the x-axis, pi over 8, and then pi over 4, 3 pi over 8, and so on and so forth. And then the y-axis, just 1, 2, 3. That's not going to be too awfully important. It would be important if you had a vertical shift or anything's going on. But we're just going to kind of just deal with our new period and what it's going to end up looking like. So the way you do this, we are going to look at how to go about actually physically graphing this thing. And so what we're going to do, and if you see those steps that I had on the screen at the beginning of the video, now that we've got everything labeled, our x-intercepts are going to be at the period. So I knew my period is pi over 4. So my x-intercept, first of all, is going to be at the origin. We know that from the parent function. And then every pi over 4 units, it's going to go across the x-axis again. So pi over 4, pi over 2, 3 pi over 4, and so on. Negative pi over 4, negative pi over 2, and kind of going backwards. So we have those, what we can call critical points. And then all we got to do there is do the asymptotes. And the asymptotes are going to be at the odd tick marks, so every other tick mark. So we have our intercepts, and then our asymptotes are going to be at the other tick marks. And that's why we did that period divided by 2. So I'm going to draw my asymptotes in here. And get a couple on the other side. There you go. And that's most of the battle right there. All we got to do now is see the direction that this thing goes. And if you remember from the parent function, I'll bring that back up here again real fast. From the parent function, we know that from left to right in each section, it is increasing. Okay, so my A value on this case is positive, so it's not going to be anything different. So in between the asymptotes, I'm just going to do that general shape and making sure I'm hitting the x-intercept as I go through there. Now, we could be more precise, but there's really not much need to. If you want a super, precise graph, that's why we have graphing calculators. But this is certainly accurate to a pretty high degree. And in case you're wondering also, the A value itself, in this case it's 2, it's just going to make the graph a little bit steeper, just like the A value always does for any other parent function. But I'm not going to be too concerned about it. Your teacher might be a little bit more concerned about making sure it's a little steeper than the parent function. But for me, as long as I see the asymptotes labeled and as long as I see the x-intercepts and the correct direction of the graph, then that's all I'm going to be looking for on the tangent function. So that's that. Let's talk real quick. What if the A had been negative? What if it would have been negative 2? What would have changed? Well, nothing really with the asymptotes and the intercepts. The only thing, it would have been literally upside down. So it would have decreased from left to right. And if you go back to that beginning screen on how to graph tangents, it's got those last 2 bullet points. So if A is positive, it'll increase from left to right. If A is negative, it'll decrease from left to right. Okay, so that's graphing tangent. I'm going to bring one more equation up here for cotangent. And if you want to pause that video, I'll let you kind of do that one on your own. Before I do that, I'll show you this real fast, though. That's your graphing cotangent directions. And you'll notice it is exactly the same, except, so we're going to define the period the same way, all that good stuff like that. But now, my first asymptote is going to be on the y-axis. And like I say, if you have a horizontal shift, obviously that will change. But for our purposes, you're going to start on the y-axis, and then your vertical asymptotes at the period, and then x-intercepts at the odd mark. So it's kind of reverse of what we just did for tangent. And then we'll talk about the direction of the cotangent function. Okay? So here is the function. And I'll let you pause the video real quick, and you can kind of take a shot of that on your own. And before you pause it, I guess I should show you the parent function of cotangent. Just like I said it was kind of backwards, but here's what cotangent looks like. Notice your asymptote on the axis, and then every period. And then your intercepts are on those, what I call the odd tick marks. And it does go kind of the opposite direction. So if A is positive, it'll decrease. If A is negative, it would be the opposite direction. So go ahead and pause the video for a second and see if you can graph that guy on your own. And then I will zip through the rest of this. All right, so A is 3. B is 1/2. Don't need to worry about the x there, obviously. Pi over 1/2 is 2 pi. 2 pi over 2 is just pi. And then you see here, I've already got that labeled for us. So, on the steps that I had up there a moment ago, we saw that on the intercept, on the y-axis rather, it's going to be my first asymptote. And then every other tick mark, in other words, at the period, we're going to have the asymptotes. So at 2 pi is going to be an asymptote. 4 pi, 6 pi, negative 2 pi, negative 4 pi, I did it again. That's going to be kind of a mess. I apologize about that. But the fact remains. So here we are going to, and every other tick mark, again, so we got our asymptotes in there, pi, 3 pi, 5 pi, negative pi, negative 3 pi, and negative 5 pi. I see what I did. Yuck. This is why you shouldn't use a pen when you're doing mathematics. But here's the deal. And also my y-axis is an asymptote. So I'm going to go backwards this time. Remember, it decreases when a is positive. So in between the asymptotes, and I'm going to come down through here. And I'm really going right here. Okay, so right here. And then my asymptotes here. This side I did okay. There you have it. And then this side is a hot mess. But, let's see, can I fix this a little bit? Yeah, I think I can. And I'm going to stop right there. Okay, so again, for cotangent, kind of the reverse of tangent, your asymptotes start on the y-axis, and then every period, every other tick mark. And then your odd tick marks are going to be your critical point to your x-intercepts. If you have different h and k values, that would obviously be different, but that's going to be, you won't see that very often, I don't think. Mainly we deal with different periods and different a values. Again, just like tangent, if a was negative, you're going to do the reverse. So if a was negative, it would increase. In fact, it would look like tangent. And then be going up from left to right. So that is how you graph tangent functions and cotangent functions. At the end of this video, there's going to be a link on the screen for where those shapes come from. If you need to take a look at that, that's a short video there. I'll also put some links in the description on graphing sines and cosines. If you want to see more videos about pre-calculus and trigonometry moving forward, please feel free to subscribe to my channel. Thank you again for watching. We'll see you next time.